What's up, party people? Ryan Stroud here for another edition of the PC Perspective Mailbag. As I bring up my questions, make sure we're all on the same page here. Again, this is pretty simple how it works. I sit here for some amount of time, 15, 20 minutes, whatever it is, and answer questions that you guys are leaving in our YouTube channel. So if you want your question answered, leave a comment on this video, and we'll filter through and pick out ones that we like, ones that we can answer, or at least not answer interestingly. And maybe you'll be featured on a future episode. Wouldn't that be great? Wouldn't that be something? Let's see. Let's go through our questions here. Metallus Mueller we'll go with. Do you think that Mantle and Vulkan, or any other low-level API besides DirectX, will matter in the future? So far, the only games with good implementations of Vulkan have been Ashes of the Singularity and Doom. Also, why did we see massive improvements with Vulkan, but not so much with DirectX like Microsoft had promised? API questions are always complex. They're always interesting. Yes, I actually do think, so Mantle doesn't exist anymore. Mantle's not really a thing. Any claims that AMD is keeping Mantle around for developmental purposes seem to be for naught at this point, right? It's been completely transferred over to Vulkan, which makes sense. There is now a consortium behind it. It's part of the Kronos group. It's where things should be. Now, will there be a future for Vulkan? Absolutely there will be. Vulkan is actually likely to become more important as we move forward because of its cross-compatibility, right? So Linux / PlayStation, but mostly based on OpenGL API is now moving over to Vulkan. The OpenCL capability is being integrated into Vulkan, so Vulkan will have compute capabilities integrated into it, which means developers will be able to more easily cycle between using systems for more easily use systems for compute or gaming or whatever, right? Whatever they want to do. So I think Vulkan actually has pretty big things going forward. A lot of things are going to happen forward. Mobile world, like smartphones, VR, dedicated headsets, all those types of things, I think Vulkan's actually going to be very important for. On Windows, and because of that, I think Windows will do that as well. And there is, was it the new Wolfenstein game? There's a game that was announced by Bethesda, I think, recently that is going to be Vulkan only, which is pretty interesting, right? So they're not going to have a DX11 or DX12 and Vulkan. It's going to be Vulkan only because they know they can target everything with it. Mac, Windows, mobile, whatever they want to do with it. And so I think there's some benefit there that will keep Vulkan around for quite a long time, and it will probably grow pretty substantially. Now, as far as why did we not see massive improvements with DirectX like we did with Vulkan, it's hard to say, right? So take a look at something that used OpenGL and then transferred to Vulkan. Here's the thing with APIs, right? I don't think anybody can deny at this point that NVIDIA did significantly better with DirectX 11 and with OpenGL than AMD did in terms of driver stack, efficiency, performance, all that stuff. So the move over from DX11 to DX12 there's a significant delta there, but it's not as much as the move from OpenGL to Vulkan. And AMD clearly, with its background with Mantle, and thus all that rolling over into Vulkan, had a pretty big advantage at the outset with Vulkan, that it was going to be able to take advantage of some of those benefits. So the increases you see on AMD going from DX11 to Vulkan or DX12 versus NVIDIA from DX11 to DX12 or Vulkan are going to differ. NVIDIA and AMD had a lot of ground to make up. It's not quite the same analogy, but if you look at what the Ryzen processor did to Intel, it had this huge jump. It had this 40% increase in IPC. They could only really do that because they were so far behind Intel before that. With APIs and games and drivers and all that type of stuff, there's a similar analogy there, right? They were behind on DX11, and they decided that rather than spend a whole lot of time trying to catch up on DX11, they're going to dedicate a lot of that to DX12 and Vulkan. And so the big jump that AMD had on the API wars is that their DX12 and Vulkan, in many cases, jumps up quite a bit, giving them closer. They're more able to match performance levels of NVIDIA's driver and driver stack. So that's more what I think happened there. Also, I mean, just keep in mind that DX12 is much harder to code for than DX11. It's more, I think you're going to see less people creating engines and more people using other people's engines because of stuff like Vulkan and DX12. Della Troy wants to know, what's the future of Moore's Law in the consumer CPU and GPU markets now that Intel and others are scheduled to release 10nm parts next year? Is there anything beyond mini-core 5nm parts? Will we see an end to increases in CPU or GPU performance in the not-too-distant future? There's a lot of questions in here. Let's see what I can address in a fairly succinct form. The future of Moore's Law is going to extend out wildly, right? So, and by wildly, I mean in an unknown state, right? It took a while for us to get to where we're at, you know, like if the move from 30s to 20s down to teens, down to the 10nm range is taking significantly longer than we had seen in the past. Every time we talk with people at Intel or people at Global Foundries about the move to the next process node technology, it's always a discussion on how much more difficult it was than the time before, how much more money and research and development time it costs to move to the next node. So that's why you're seeing an extension of the use time of these nodes as we're at now, like 14nm. Intel's using it across multiple generations opposed to just two, because they need to recoup more of that cost. They need to increase their value out of the time they spent developing that. You know, we'll see stuff beyond 10. How long will it take? I don't know. This is really more of a Josh type question. Even then, we're both kind of just hypothesizing and guessing based on what other people are telling us. You know, I don't think we see an end to CPU or GPU performance increases. I do think, you know, process nodes give you two advantages. One is they give you the ability to run at higher frequencies, and two, they give you better density of space. So yes, do I think we'll see more cores on GPUs and on CPUs as we move forward? Yes. Do I think we'll see less of an increase in clock speed as we move forward? Yes, I do think that's the case as well. But I don't think we'll stop seeing performance increases generally across that. Keep in mind that GPUs benefit from more cores, right? So if we have 4096 shaders on an RX Vega today, if you can get twice that, if you can get 8,000 plus shaders on a Vega card, that's going to improve gaming performance. That's going to improve compute performance. There's all kinds of advantages there. Now on the CPU side, because of out-of-order architectures, it doesn't quite scale as cleanly and as magically as GPUs do. Yes, it's a more complex problem, and if we could just get more frequency out of it, we'd be beneficial. If we had processors running at 10 gigahertz effectively today at the same thermal levels, same cooling capabilities, then obviously we'd be better off than we were kind of here at the 4,000 range, right? So it's a complicated story, but no, I don't think we're going to see a drop. I don't think we're going to see things slow down, if that helps. Green Bits asks, I have a 1080p IPS FreeSync monitor and a GPU with 4 gigs of RAM. Will games need more than that for 1080p in the future? Difficult question, again, to tell the future. I would say probably not. Keep in mind that even if you have running at 1080p and you're using near 4 gigs now, or you're high resolution and you're using more than that, like, game settings are what changes that. Look at a game like GTA 5. As you adjust the settings for the game, it tells you how much memory you're going to need. Those are estimates, things change in real time, et cetera, et cetera. But even if you have a 4 gig graphics card for another year or another 2 years, and you're still using that 1080p IPS FreeSync monitor, the ability to turn down a couple of game settings to maintain a more stable frame rate is really the advantage you get there. And that's, I often tell people, you know, PC gamers have this mindset of, I want to turn up everything all the way, all the time, and if I don't get the performance I want, damn it, this hardware is not fast enough. I would look at it a different way and say, I want to get this frame rate. I'm willing to turn off a couple of settings in order to get to that frame rate. And your benefit already, Green Bits, is that you have a FreeSync monitor, so the variable refresh capability means that if you're running at 45 frames per second versus 65 frames per second, you know, you're still doing really well, right? You're still able to have a smooth and effective and efficient and reliable gaming experience. So I wouldn't worry too much about the 4 gig frame buffer or GPU memory that you have on board quite yet. Similar question, V8 Flexin wants to know, I'm planning on going with a 1080p triple monitor setup. I would like to use FreeSync capable monitors with a single RX Vega 64. I prefer to have 60 FPS average at max game settings. Will RX Vega 64 handle it, or should I just go with the 1080 Ti and regular 60 Hz monitors? This is going to vary a lot game to game. If we kind of look at a worst case scenario, look at something like Witcher 3 or Rise of the Tomb Raider, some of these games that are very heavy, graphics limited games, I think an RX Vega 64, which is essentially a GTX 1080, is going to be able to have performance at or above the 60 frames per second for a 1080p triple monitor configuration. If I do the simple math here as I type this up, because I didn't plan this out very well ahead of time, right? 1920 times 1080 times 3. Nope, I still didn't type that in right. Is 6.2 million pixels, whereas a 4K monitor is 8.2 million pixels per frame. So you're well under 4K render rates there. If you have games turned up really high, if you're aiming to have max image quality settings, I think 60 frames per second you'll probably do fine on a Vega 64 if you can find them, if you can get them at the price you want. If you can't, a 1080 Ti is the same price range. It's going to be a better performing part. Now, if you already have the FreeSync monitors, that's kind of a disappointment. And if you want to go with the G-Sync displays, it is going to be a more expensive proposition for you. So I would caution, depending on your budget, what it's going to be, that going to the more expensive displays is going to be, if it's $100, $150 more, multiply that times 3 in your configuration, which is a problem. Virtual Greg wants to know why are there not more laptops with 1440p screens? Do we really need 4K on a 15-inch screen? Honestly, no, we don't need 4K on a 15-inch screen, and the reason they're doing that is just for pixel density, right? It's not really for gaming purposes. It's more for productivity purposes and being able to get better pixel density, better image quality in Windows production and content creation, those types of things. I just don't know, the laptop vendors are kind of beholden to what the display vendors are willing to build, right? So if they don't want to, if the display vendors aren't building 17-inch or 15-inch 1440p screens, then they're not going to be able to build laptops on it. And only the biggest of customers are going to kind of be able to go in and create or demand or request specific resolutions for those types of things. You see a lot of like the Dell XPS 13, which is a 13-inch screen, essentially 13.3-inch screen that has a 1080p option and then a QHD Plus or whatever they call it. It's like 3800 by 1200. And the higher resolution screen looks really nice. It's super sharp and very vivid, but it's also power hungry. It also uses a lot more backlight. It requires higher brightness, requires more GPU horsepower to push stuff through it, and as a result, you lose a lot of battery life. So, 1080p for me on a 14-inch screen, which is what my Lenovo X1 ThinkPad X1 Carbon uses at 1080p. I kind of even there am using scaling. I'm using 125% scaling in Windows because at native at 100, I have old man eyes and it's hard to see. So I think that's kind of your reason there. Eric Elsinger wants to know, I heard I will only be able to watch 4K Blu-rays on a PC with a Kaby Lake processor. Is that only dependent on the processor, or do I need a Z270 chipset also? For example, would I be able to watch 4K Blu-rays on a PC with a Z170 chipset and a 7700K? Keep in mind here that there's no... This is more of a decode function capability. So in my book, as long as you have the right processor, the 7700K, the Kaby Lake part, it shouldn't matter what chipset you use, unless there is a DRM issue of it passing through digital outputs. Although I don't think there's going to be any differences between the Z270 and the Z170 there. So you should be able to watch 4K Blu-rays on a PC with a Z170 chipset and a 7700K. If anybody watching knows better that you cannot, please let us know and let Eric know in the comments. Yeah, and keep in mind that there's other stuff like Kaby Lake was the first processor to be able to support Netflix 4K because it had H.265, HEVC decode capability, not because of any DRM issues or performance issues. It's just a decode acceleration really that allowed it to do that. So I guess that is kind of a performance issue, if you will. Thanks, Eric. Let's see. I got time for a few more. If you hear any stuff in the background, that is the lawn service cutting the lawn at the office, and there's a weed eater that they drag along the side of the building, so I apologize in advance for that. Tommy Peel asks, why doesn't NVIDIA or AMD just build the fastest gaming video card they can, ignoring cost and power usage? For example, a fully unlocked GP100 based card from NVIDIA. I imagine that there would be some market for something like this, given the people getting the multiple 1080 Ti cards for SLI. With the incoming high refresh rate 4K panels on the horizon, it would seem that faster single cards would be useful. Tommy, you are 100% correct in that faster single GPU cards are the best solution possible. Better than SLI, better than Crossfire, multi-GPU, all that stuff. Faster single GPUs are better. Now, what's interesting, you bring up a fully unlocked GP100. GP100 is the Pascal-based compute card used in enterprise compute servers, AI, machine learning, all that type of stuff. It is a very different part. It uses HBM2 memory. But if you look at its performance in gaming, the Titan XP, Titan X Pascal is probably at or beyond it in terms of gaming performance, because it's all based on single precision compute capability. Whereas in the GP100's case, a lot of its measurement and workload and performance is based on double precision performance for some of these enterprise CUDA-based compute workloads. So a fully unlocked GP100 base card for a gamer wouldn't really be an upgrade in many cases, and it would be significantly more expensive based on how they're pricing everything else. So the 1080 Ti / the Titan XP that NVIDIA released most recently is going to be better at gaming than a GP100 today. But the original question of why don't they build the fastest card they can, ignoring cost and power usage, that's a pretty big risk, right? Designing a new chip for specifically targeting no cost or power restrictions is expensive. You got to validate it, you got to produce it, you got to predict yield, and then you have to make so many of them in advance and hope that people buy them at the prices that make sense for you. Also, you don't want to undercut the value proposition of what you're selling to your enterprise and Quadro customers, right? So there's a whole lot of other decisions that go into that. Take for advantage, the AMD has built and released a 350 watt video card, right? The liquid cooled Vega 64 is a 340 watt TDP video card, graphics card. What could NVIDIA do if they allowed themselves to use 350 watts on a GP102, for example? How high could they clock it? It would be less efficient. You would get less performance per watt out of it than you do today, but you'd definitely be able to get more out of it if they're willing to go 100 watts higher. Now, NVIDIA's in a space now where they don't have to worry about that. They're already in the performance lead. They're already putting AMD to the screws in a lot of areas in terms of the high performance and efficiency and technological advantages. But why not? Why wouldn't they release a 300 or 350 watt card, put a liquid cooler on it? AMD's done it a couple of times. NVIDIA never had to. They still don't have to. But if they wanted to appeal to that specific user, there's no reason they couldn't maybe get another 15% over 1080 Ti. But how many people are going to be willing to pay 50% more for 15% additional performance, right? And that's really what it comes down to. There are definitely people out there, but it might be a smaller audience than you think based on the development costs. Let's see. Persona Shinde asks, can you explain the difference between 60 Hz versus 144 Hz versus 165 Hz versus 240 Hz monitors? What transition would be most noticeable? So I assume everybody watching this understands what that means. The 60, 144, 165, 240 Hz is the number of times the monitor refreshes per second, right? So 60 frames per second, 60 Hertz, 60 refresh cycles per second versus 144 all the way up to 240 Hz. The more refreshes per second you get, the smoother the animation can feel, especially if you're in Windows. The difference between a 60 Hertz, like just moving a mouse cursor around at 60 Hertz versus moving around at 144 is dramatic. If you've never done that before, find a friend that has a 144 Hertz display, use it, move windows around, type, do whatever you're gonna do, pick up a window and move your mouse cursor, and then switch that monitor back to 60 Hertz refresh, and then do the same thing. You'll immediately see a difference. and it's pretty compelling from in a Windows kind of productivity standpoint. From a gaming perspective, what the higher refresh rates allow you to do is, if you're in a variable refresh like a GeForce or G-Sync or a FreeSync, you can run at higher frame rates and still have the lowest possible latency and the best smoothness experience, because you're not peaked at, capped at 144 hertz G-Sync or 160 hertz G-Sync or whatever it happens to be. Now, if you run it VSync off, one of the benefits, if you don't have variable refresh, or you don't want to use variable refresh for whatever reason, if the higher your refresh rate of your monitor, the less likely you are to see visual tearing on the screen, horizontal tearing from VSync being disabled, because it's drawing more frequently. So if your frame rate is 100, if you're running the game at 100 FPS, but you have a 240 hertz monitor, the likelihood of you seeing those horizontal tears is going to be much lower than if you had a 60 hertz monitor, VSync off, and you're running at 120 frames per second, right? So that's a benefit to those higher refresh rates monitors. Now, in terms of what transition would be most noticeable, I think the 60 to 144 is going to be your biggest differentiator. Now, 144 to 240 is going to be a pretty big one as well. 144 to 165, not as much, but in much the same way that, going from a hard drive to an SSD was this big jump, a SATA SSD, but then going from a SATA SSD to an NVMe SSD, there's significantly less of just a feel difference on the system. I think it's the same, right? 60 to 144, especially if that's your first time going to a high refresh display, you're going to notice it immediately. You're going to see the benefits that it provides. Going up to 165s, you're going to see maybe something out of it. Going up to 240 might be another one altogether. And then if you want to get that the 1080p 240 hertz G-Sync display that also can do ULMB, I think at 144. If you don't know what ULMB is, we'll talk about it some other time. Ultra low motion blur. It basically pulses the monitor backlight at a different point to reduce any kind of motion blur in fast moving objects. And being able to do that at 144 hertz is pretty awesome. So keep that in mind. Let's see. Maybe one more question from Antonio Cunningham. Hope I'm not biting off too much here that I can chew in a couple of minutes. What's the best or optimal way to build a PC? For example, if you want to build a PC for $500, what percentage should go into CPU, GPU, RAM, etc.? Oh man. So this is a tough one because it really depends on what you're using the PC for. If we're talking about a gaming PC, then you want to overemphasize the graphics card. $500 is not a very high budget for this type of scenario. Maybe let's make it $1,000, so it's a little bit easier for me to work in my head. If you could build a $1,000 computer, to me for gaming, I'll probably want to spend $300 to $400 of that on the video card. So we're talking, $399 for like a GTX 1070 or an RX Vega 56 if you can find one, right? Now that's a significantly high amount of your investment, but that leaves you $600 or so to build out the rest. So you can spend, $200 on a CPU, $150 on a motherboard. That's $350. Maybe might be stretching it at this point because now you need to get an SSD. You have to get an SSD. Don't only buy a hard drive now, but if you get a 250 gig 850 Evo for $130, you can probably get memory for around $100, maybe a little bit less, for 16 gigs of RAM. Yeah, you're in the ballpark. Although maybe the $400 purchase of a GPU is going to overweigh it there. So if you back off to like a GTX 1060, you're going to save another $100 or so, $80 to $100, which maybe give you more flexibility with your case and your power supply and whatnot. I think the way to think about it is, what is my primary workload? If my primary workload is gaming, that should be your heaviest emphasis would be on your GPU. If you are a video editor with some light gaming, then you might want to do a better balance of your CPU and your GPU, right? So maybe 250 on the processor, 250 on the GPU, more memory in your system, that type of way. There's no really hard set limit here. I would say for most of the people who are watching this, they're kind of gaming centric, they're enthusiast centric, so there's just going to be a heavier weighting to it. I think for a $1,000 system, $300, maybe $400 if you want to stretch in a couple of other areas, is the right way to go for the graphics card, right? Which is where you want to spend it there. you can get a Ryzen 7 1700 CPU for like what, $240 I think, or something like that, right? And then you can get a B350 motherboard for $100 and go up from there, right? So it really is kind of it's like building a puzzle, right? When you have a hard cap of a price of $1,000 or $500 or whatever it happens to be. 500 is really tough to do, by the way. So here like it's like building a puzzle. It's when I was planning out the office and where I was going to put different pieces of furniture and stuff. I was a nerd, and I did a page of graph paper, and then I would cut out the size of the desks that I had and the size of the studios that we had and all these other things. And I would I'd move them around and place them until I found the optimal position. And that's kind of what you do when you're building a system, right? You can go to something like PCHound.com, or you can go to PC Part Picker and start to do some builds, right? And say, okay, well, if I start with the 1070, what kind of system can I build in, say, under 1,000? Okay, what if I start with the 1060? What can I get? Or, hey, I know I need the 250 gig 850 Evo, and I know I need the Ryzen 7 1700. Put those two in there, build out from there, right? And those types of websites have really good tools to help you create that type of stuff and keep it going. So that's going to be it for this week, everybody. Hope that was interesting. Hope you found it useful. Make sure you leave your questions here, like, subscribe, comment, all those types of things. Start sharing these videos if you find them interesting. If you have any other suggestions for things we can do for content that you think would be cool and interesting, please let us know in the comments as well. We definitely are, especially on these videos, we're watching the comments very closely. So we will be busy the rest of the week. We've got our podcasts every Wednesday. We've got our PCPer Plays on Tuesdays. We've got this video that goes up on Fridays. So hopefully you guys are staying entertained as we move forward. So thanks everybody for joining us. I will see you next time.